These are examples for section 5, 7, 1 and 2 triangle inequalities. Example 1. Let A equal 8, B equal 7, and C equal 1 show that the comparison property of inequality can be verified. Reviewing the comparison property of inequality, which says if a number A equals the sum of two other numbers, B and C, and the second one of those numbers, C, is greater than 0, then A must be greater than B. We apply it to these values, and we have if A, which is 8, equals B, which is 7, plus C, which is 1, and that's true, 8 equals 7 plus 1, C, which is 1, is greater than 0, which is true. All of this is true. Then A, which in this case was 8, must be greater than B, which is 7, and that's true. Verified. Example 2. Use the figure at the right. Y is the measure of angle 2 greater than the measure of angle 3. Using the triangle exterior angle corollary, which says the measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles, we can say angle, since triangle BDC is isosceles. It's isosceles, according to these two sides being congruent, by the triangle isosceles theorem. The measure of angle 1 equals the measure of angle 2. Again, by the isosceles triangle theorem, because these two sides are congruent, the angles opposite them must be congruent. Then, by this new corollary, the triangle exterior angle corollary, the measure of angle 1 is greater than the measure of angle 3. 1 is greater than 3. Then, by substitution, the substitution property, we can say that the measure of angle 2 is greater than the measure of angle 3. We take the measure of angle 1 here. Since it equals the measure of angle 2, we replace the measure of angle 1 with the measure of angle 2 here. So this is why the measure of angle 2 is greater than the measure of angle 3. Example 3. A town park is triangular. A landscape architect wants to place a bench at the corner of the largest angle. Which two streets form the corner with the largest angle? It's supposed to be form. The largest angle. To do this problem, we need the triangle opposite inequality theorem, which states if two sides of a triangle are not congruent to each other, then the larger angle lies opposite the longer side. So, in this particular park here, this triangular park, we have Valley Road, we have MLK Boulevard and Hollingsworth Road. This is 175 feet, 105 feet, 120 feet. So if we take the longest road, which is Hollingsworth, 175 feet, since Hollingsworth is the longest, 175 yards, and its opposite angle over here, it is opposite the largest angle. So, the two streets that create the angle where they're going to put the bench are MLK Boulevard, and Valley Road form the largest angle. For the bench. So since Hollingsworth Road is the longest, then across from that has to be the largest angle. Pretty simple. Example 4. Write the sides of triangle TUV in order from shortest to longest. Here we have triangle TUV, and we've got two of the three angles. First of all, before we can do that, we need this angle right here. If we have all three angles and they're different in measure, then we can tell which opposite sides are longer and shorter. So we use the old triangle angle sum theorem to state that the measure of angle T plus the measure of angle U, which is 58 degrees, plus the measure of angle V, which is 62 degrees, is equal to 180 degrees. Solving for the measure of angle T, adding these two, we get the measure of angle T plus 120 equals 180. Subtracting 120 from both sides, we get the measure of angle T equals 60 degrees. So now that we know the measure of angle T is 60 degrees, place that there. We can take a look at the angles now using the triangle opposite inequality theorem. This is the smallest angle. This is the smallest angle. This is the largest angle. And so our shortest side would be across from the smallest angle. So since this is the smallest, we start with TV is our shortest, and then 60 degrees is the next one. So UV would be the next one, and then finally the longest would be across from the biggest angle, TU. So these are the sides of this triangle in order from shortest to longest. That's by the triangle opposite inequality, Converse. Example 5. In example 5, can a triangle have sides with the given lengths? And then explain. So they're asking if a triangle can be formed using these three lengths, 3, 7, and 8. And when you think about it, sometimes if you're given just any three values, it doesn't necessarily form a triangle. For instance, if I have a triangle, if I have three sides and one is, let's say, 5 units long, another one is 6 units long, and a third one is 15 units long, well, the one that's 15 is way too long for the sum of these two. So 5 plus 6 is 11. It's too short for this 15. So anyway, it doesn't always work. So to tell, we can use the triangle inequality theorem. Basically, it says that in any triangle, the sum of any two sides has to be greater than the third side. And so there's three combinations that we need to try out here. So for part A, by this theorem, we're going to do three statements. We're going to take 3 and add it to 7. Just take two of the sides and add them together. And it should be greater than the third side, 8. I'm going to skip some space. We're going to do it again in a different combination. Let's take 7 plus 8 feet should be greater than 3 feet, the third side. And then finally, the last combination would be 3 plus 8 should be greater than 7. So solving each one of these inequalities, very similar to the way we solve equations. 3 plus 7 is 10, is greater than 8. That works. It's true. 7 plus 8 is 15. It's greater than 3. That's true. 3 plus 8 is 11, and it's greater than 7. And that's true. Since all three of these are true from the triangle inequality theorem, these three sides will form a triangle. So yes, the sum of the lengths of any two sides is greater than the third. Part B, same instructions. Can these three measurements be side lengths of a triangle? Using the triangle inequality theorem once again, we have three different combinations and three inequalities. 5 plus 10 should be greater than, we're going to try this out as greater than 15. 10 plus 15 should be greater than 5. And then finally, the last one is, let's see, 5 plus 15 should be greater than 10. So starting off with the first one, 5 plus 10 is 15. 15 is greater than 15. Well, that's not true. 15 is equal to 15. It's not greater than. So already we know that these three won't work. We just happen to try the one that doesn't. Let's see if these actually worked. 10 plus 15 is 25. It is greater than 5. 5 plus 15 is 20, and it's greater than 10. So although these two worked, since this one did not work, no. The sum of 5 and 10 is not greater than 15.